And the next presenter is Andrew Olson, who continues the single potential energy surface description, but he will try to bring it closer to real world. So he'll present on this practical reaction.
Alright, so I'll talk about the combustion of rocket fuel, specifically hydrazine and dinitrogen tetroxide. So there's three main categories of rocket fuel. Essentially what you need to know from this slide is that these two require an initial energy to overcome the activation energy, and hypergolic, which I am focusing on, it does not require. This says reacts on contact. So yeah, hypergolic fuel, it's spontaneous, like I just said. It's useful for really precise movement. So let's say you have a spaceship you want to land on the International Space Station. Because it's so like instant almost, the movement, it's really precise and you can land it and get those really precise movements of thrust. But the downfall is that it is toxic, so they only use it at the moment for unmanned spacecrafts. So there's three main types of hypergolic fuel. There's hydrazine, and then these two, monomethylhydrazine and unsymmetric dimethylhydrazine. The only difference is in place of an NH bond, they add a methyl group. So when you add the two methyl groups, or the one or two methyl groups, the difference is that it lowers the freezing point, which is beneficial because they wouldn't need as much heating supply if they bring it in, like if they store it in space. And then it also, the downfall is that it lowers the specific impulse or the thrust. So this is a representation of the activation energies. So as you can see, the blue is the N, the white is the H. So the NH breaks as it overcomes that first barrier. Then you can see it slowly shifts over to the OH. So this is this green is activation energy, and this one is with 0 initial momentum, and as you can see, it still overcomes the activation energy pretty easily. Like I said earlier, spontaneous. And then for this one, just to get a different perspective, I bumped the initial momentum up quite a bit, and again, it overcomes the activation energy pretty easily. And this is the amount that goes to completion of the reaction. So as you can see, it jumps up pretty quickly, but it does get a little wavy, and I think that's due to just MATLAB error, because it did bounce back off the sidewalls on the video that you just saw. So yeah.
Okay, well, thank you.